Hi guys, now let's get to second property of light, which is the luminous flux. Luminous flux is the rate at which light is emitted from a source, and it's measured in lumens. It shows us how much light is bright or dim, so it measures the brightness of light. However, a luminance is a luminous flux divided by area of a surface, which is measured in lumen per meter square. So a luminance is luminous flux but in a specific area, or a specific area. For example, here if you can see, we have a large square. This is the luminous flux, but every small square inside that large square is called as a luminance, because it's measured in lumen per meter square. So for a small specific area, we can say this is the illuminance, which again gives us how much a light is bright or dim. We have a note here. It says less light falls on each unit square as the distance from the source increases. So here we can see a small square. Here we have, but the intensity of light in this small square is very large, very high. But as the area increases, the intensity of light decreases. The intensity of light decreases as the area increases. We have a question here. It says, what is the relation between the illuminance of light from the source and the illuminance of light away from the source? If you can look at the figure, we have illuminance in here in a small square and illuminance in the large square. It says, what's the difference between those two sources, or those two illuminances in this figure? We can say it as the answer. It says illuminance decreases as the radius squared when you move away from the light source. So in here, as we said, intensity of light is high, it means illuminance is high. But here, as we pass a large distance from the source, here we have 3 meters, for example, the illuminance of light decreases, or we can say the intensity of light decreases. Now we have some special cases, as the question says here. Why astronauts, while observing galaxies, talk about past or long time ago? Talk about long time ago. The answer is because light that reached us from galaxies emitted from millions of years ago. So the light that reaches us from stars takes millions of years because of the large distance between us and the stars, except the sun, of course. Another question says, can we say bright stars at night always have more light than the dim ones? So if you look at the sky at night, we can see some stars are brighter than others. That does not mean that the bright star has more light. As you can see, the answer says no. Maybe stars are closer to us than the dim ones. That's why they look bright. So if the star is closer to us, its light will be bright. If it's far from us, its light will be dim. But that does not mean that stars has dim light. Now we can get to section 5.1. We have 3 questions here. Those 3 questions are important for you. First one says, identify which portion of electromagnetic spectrum is used in each device's list. Microwave oven, television set, single lens reflex camera. You can see the answer from a microwave oven. It uses microwaves. Television set uses radio waves, and camera uses visible light. The second question says, if we have an electromagnetic wave has a frequency 7.57 times 10 to the power 14 Hertz, what is the wavelength? It says find lambda. To what part of the spectrum does this wavelength belong? We can see the answer here. If you can use this rule to find lambda. lambda is equal to c over f. C is the speed of light and f is the frequency. So we said speed of light is constant, 3 times 10 to the power 8, divided by 7.57 times 10 to the power 14. You can get the result 3.96 times 10 to the power minus 7. The third question says Galileo performed an experiment to measure the speed of light by timing how long it took light to travel from the lamp he was holding to an assistant about 1.5 kilometers away and back again. Why was Galileo unable to conclude that light has finite speed? The answer says because the speed of light is very high and could not be measured from short distances. Thank you for listening.